This is the second part of our lesson on section 4.2. We talked about the third angles theorem last video, where if you have two pairs of congruent angles in a pair of triangles, you know that the third pair of angles must be congruent as well, even if you don't know their measures. So we're going to use that third angles theorem to find the measure of angle BDC. Angle BDC is this angle. So notice how we have a yellow triangle and a bluish triangle. In the yellow triangle, we have a 45-degree angle with one arc on it. So that means this angle is 45 degrees. We have a yellow triangle where we have an angle with two arcs on it that's 30 degrees. So that's the measure of this angle also. We do have two pairs of congruent angles. Now, whatever the angle is over here, this third angle on the yellow triangle, the one that looks like this, whatever that angle measure is, that'll be the same as the measure for angle BDC. That's an awful looking triangle, but it would be the measure of that one as well. So 45 and 30 make 75. So that means this angle has to be 105 degrees. So if this one's 105 degrees, what's the measure of this one? It's 105 degrees as well. Let's prove that these triangles are congruent. They give us some information. Segment AD is congruent to segment CB. So I'm going to put those marks on there. Segment DC is congruent to segment BA. So I'm going to put those marks on there. Notice how I use two marks here because these aren't necessarily congruent to those. Also, angle ACD, that's this angle, is congruent to angle CAB, that's this one. Angle CAD, that's this one, is congruent to angle ACB, that's this one. Then again, I'm using different arcs here than I did there because those aren't necessarily the same. All of this stuff right here, I'm going to save some time and I'm not going to write it in there. You need to write it in there, but I'm not going to do it because I'm writing with a mouse. So that's given information. So you have four pairs of congruent parts. You need to list two more pairs of congruent parts for the triangles to be congruent. So we know that segment right there, segment AC, is congruent to itself. It's on both triangles. Just watch the order. Segment AC goes with segment CA because these triangles aren't translated. That's the reflexive property. Can't even type. Also, we have angle D and angle B. They're not marked congruent, but we know that they are because we already have two pairs of congruent angles. So the third pair of angles are congruent too. That's your third angles theorem that we just talked about. Now, if you look at your picture at this point, you have six pairs of congruent parts marked. That means that the two triangles are congruent. So triangle ACD is congruent to triangle CAB. And that's your definition of congruent triangles. Theorem 4.4 talks about properties of congruent triangles, so we have the same reflexive, symmetric, and transitive properties that we're aware of, but this theorem is telling you that it works for triangles also, not just segments or angles or numbers. So if you have a triangle, it's obviously congruent to itself. If you have two triangles and they're congruent to each other, they're congruent to each other either way you write them. And then your transitive property says if you have three triangles and any two pairs of them are congruent, then that third pair would be congruent as well.